Hi, hello everyone. Welcome back to our channel Samarth Official. In this video, you will learn about how to find the maximum deformation and distribution of von Mises stress on a combination range shown in the figure. This problem can also be solved under 2D analysis. The dimensions, loads and constraints are given here. You can take the screenshot of this problem and try to solve this. Open ANSYS Workbench, minimize analysis systems, expand this component systems. So go to geometry, okay? Click on this, drag this and leave it here. So this will be created. Just rename this. I'll name it as combination range. Select this. Ensure surface bodies is in tick, okay, is selected, and in analysis type change it to 2D, okay. Select this geometry, right click, new design modeler geometry. So it will take you to design modeler interface. Just wait for some time, it will open the design modeler interface. Now select any one of these planes. I will select XY plane, right click on look at, okay. Now go to sketching. Before sketching anything, you need to change the units. Go to units, change it to millimeter, okay. Now select a circle. So I want to draw a circle here. Select the circle. So select the center point, drag it and leave it here, okay. Now click on the dimensions. Select this. Before selecting this, you just select this radius. I need to give the dimension of the radius here. So this is R1. So R1 will be shown here. So the value of R1 is 10. Press enter. Right click, zoom to fit. So you can see this. So now again go to draw command, select a circle, draw a circle, click on dimensions, click on radius, select this circle and give the value of R2 as 12.5. Press enter. Okay. So now take a line, go to draw, take a line, click on this circle and click on this circle. Ensure H means horizontal line. Okay. Again a line is selected. Again select this and again click on the circle. Ensure the line is horizontal. H comes here. Okay. Now go to minimize this, draw command, or else go to constraints, click on symmetry. First select this center line, select this top line and select this bottom line. So these two lines are symmetric about this axis now. Okay. Go to dimensions. Okay. Click on vertical dimensions, select this line and select this line. This is V3. So this value is 12. Press enter. Okay. Now go to draw command, select the polygon, n is equal to 6. You need hexagon to be drawn here. Select the center. Ensure this line is horizontal. Click here. Now go to dimensions, general, select this line, drag this, and the value of this H7 is 40. Okay. Enter F7, zoom to fit. Okay. Now go to draw command, select this rectangle, click on auto fillet. Okay. Draw a random rectangle. Now go to constraints, click on symmetry. So select the center line, select this top line and select this bottom line. So this is symmetric about this horizontal axis. Okay. Now again go to dimensions. So I need horizontal dimension. Select this. Okay. Select this point and select this line. This is H8. The value of H8 here is 10. Okay. Now go to modify. Select the trim command. So select this all lines, unwanted lines to be removed. Okay. Press escape. Again, click on dimensions. Vertical. Select this line and select this line. This is V9. The value of V9 is 12. Press enter. So now again select the dimensions, click on radius, select this, fill it. This is R10. The value of R10 is, so give the value of R10 here, which is 2.5. Press enter. Okay. You can see this fillet is also changed. Select sketch, go to concept, click on surfaces from sketches, click on apply, click on generate. You can see the 2D model of the combination branches created. Okay. Go to file, close design modeler. Now minimize the component systems and expand this analysis systems. Go to static structural, click on this, drag here. You will get this red box like share A2. Now you leave it here. So you'll have a connection with this geometry to the static structural analysis procedure. Okay. So now select this model. Click on the geometry and ensure analysis type is 2D or not. Click on the model, right click, edit. So this will take you to this modeling part where you will go for meshing and giving the loading and giving the constraints. You need to wait for this interface or workbench to open. Okay. Now select this mesh, right click, generate mesh. Okay. Again, select the mesh, right click, insert, sizing. So you can change the size. Now the default size is 3. So I'll give it as 1.5 mm. Okay. Now geometry need to be selected. Okay. For this, you ensure this is surface, face is selected here and select this face. Click on apply. Select the mesh, right click, update. You can see the mesh size has been changed based on our input. Now select the static structural, right click, insert. Okay. Now you need to give the constraint to this hexagon part. Okay. Fixed support, select the fixed support, and now ensure this is edge. Select this edges, press Control and select all these edges. Okay. Click on apply. So you can see fixed support is given on all these edges. So now again go to static structural, right click, insert. So now you need to give pressure. Okay, go to pressure. So again ensure this is an edge and select this line or edge, you can say. So you can change it to vector. The magnitude here is 2 megapascal. 2. Okay. So you have already selected the geometry, click on apply. Means you have already selected this edge. Okay. So you can see, right click, solve. So here, this is not solved. Why? Because you can see the pressure has a question mark here. Now in order to means like the data for pressure is not given completely. So select this pressure. So you can see here direction is not defined. It is still showing yellow color. So now select this and select any of the edge. I need this vertical direction to be selected. Select this edge, click on apply. So you can see this pressure is applied in the vertical direction, which is nothing but y direction here. Okay. Now again select the static structural, right click, solve. So you can see the pressure, before pressure there is a green tick mark. Now all the data is given properly. So wait for the system to solve the solution. So solution is solved already. You can see tick mark here and here, green tick marks. Okay. Now you need to view the solution. Now solution is already solved. In the post processor, you need to view the solutions, whatever results you need. Select the solution, right click, insert, okay, deformation, and select the total deformation. Select the solution, right click, insert. So we need von Mises stress. Go to stress, equivalent stress, which is nothing but von Mises stress. Select this. Okay. Select the solution, right click, evaluate all results. So this will evaluate your results. Your results are evaluated. You can see tick mark here and here, green tick marks. Now to view this solution or results, solution is already solved. To view this results, select this total deformation. So you can see the total deformation. In order to check for the animation, you just click on play button here. You can check the animation. So this is the maximum deformation and this is the minimum deformation. Red color indicates the maximum deformation and blue color indicates the minimum deformation. Okay. So you can minimize this also. Again, if you want to look into equivalent stress values, select this equivalent stress, which is nothing but von Mises stress. The units is megapascal and the maximum von Mises stress is 160.77 megapascal and minimum is 7.67 into 10 power minus 6 megapascals. Okay. If you want to look into the animation, just click on play button. So you can see the animation here. You can see the maximum von Mises stress. So here the stress concentration is more. So you can see the maximum stress that is seen here. So this blue color indicates the minimum stress. Okay. Thank you.